Okay, let's dive into this. When I first heard about that U.S. rapper, B.O.B., back in 2017, trying to crowdfund a satellite.
Oh, yeah, to find the curve. Right.
Exactly. I mean, I just figured, okay, publicity stunt.
Sure. Seems likely.
But the eye-opening thing is how many people actually believe the Earth is flat, like a disc.
It's not just a handful.
Yeah,
Yeah.
millions, apparently. It's not a joke for them. It's a real conviction.
Mm-hmm.
So that's our mission for this deep dive. We want to explore why these flat Earth views seem to be, I don't know, gaining traction.
Getting louder, certainly.
Yeah. And understand the mindset. And obviously we need to revisit the science, the actual proof that Earth's a globe.
Absolutely. The fundamentals.
We've pulled together insights from various sources, researchers who actually went to their conferences.
Right. First-hand accounts.
So you, the listener, get a kind of shortcut to understanding this pretty astonishing topic.
Yeah, it's pretty striking, isn't it? I mean, as someone in physics, you first hear it and just bafflement, really.
I bet.
But it's definitely a real thing. It's growing. You've got these yearly conferences in the U.S.
Attracting hundreds of people.
Yeah, hundreds. And YouTube is it's still packed with videos claiming evidence.
Still.
Oh, yeah. So it's not just some fringe thing anymore. It's actually kind of a unique window into science denial.
And how belief works, maybe.
Exactly. The nature of belief itself.
It is tempting to just dismiss them, though. I say they're just trolling online.
It's an easy assumption.
But people like Lee McIntyre, the philosopher, and Ashley Landrum, the psychologist, they actually went to these flat Earth events. What did they find? Were people serious?
Completely serious. That was the main takeaway. Landrum talked to, I think, over 90 people in the community.
90.
Yeah. And she said they were all deeply earnest. They genuinely believe this stuff. It's not an act.
Huh.
And you see it in the lectures they give there. Things like talking to your family and friends about flat Earth.
Wow. Practical advice?
Or NASA and other space lies. Even things like 14 plus ways the Bible says flat Earth.
So it's a whole ecosystem.
It really is. Built entirely around this core belief.
It's strange because historically, didn't we sort this out ages ago?
That's what's so remarkable. I mean, you had the ancient Greeks, right? Aristotle noticed new stars appearing when he went south.
Ah, right, proving curvature.
Exactly. And Eratosthenes, 3rd century BC, he calculated the Earth's circumference with sticks.
Amazing.
Then Islamic scholars refined it, European navigators sailed around it, and, obviously, space travel gave us pictures. Definitive proof.
So how did the flat idea even come back?
Well, it had a resurgence in the 1800s. It was sort of a backlash against science, often linked to very literal interpretations of the Bible.
Okay.
There was this British guy, Samuel Rowbotham. He proposed Earth was a flat disk, North Pole in the center, and Antarctica was an ice wall around the edge.
An ice wall.
Yeah.
Okay. And that society, the International Flat Earth Research Society from the 50s, I always thought that was just like peak British eccentricity.
Maybe a bit. But it got a huge boost in the early 2000s. The internet really fanned the flames.
Ah, the internet. Of course.
And the Flat Earth Society officially relaunched in 2009. That's when the conferences really started picking up steam.
So digital space has just amplified it all.
Massively. It shows how these niche ideas can find new life online.
Which makes you wonder, what do they actually think the Earth looks like? Is there one standard flat Earth map?
Well, that's the thing. There isn't just one model. There are several, and they often contradict each other.
Oh, like what?
So some stick with Rowbotham's idea, the disk with the ice wall holding in the oceans.
Right.
Others imagine it more like a snow globe, a flat base with a big dome over it, holding in the atmosphere.
A snow globe Earth. Okay. How do they explain day and night then?
Usually they say the sun isn't this massive star millions of miles away. Instead, it's relatively small and close.
Small and close.
Yeah, like maybe only 50 kilometers across, circling above the disk like a spotlight. The U.S. model often puts it around 5,500 kilometers up. The moon does the same.
A tiny spotlight sun.
And then you have models like the U.K. model that reject gravity altogether.
Wait, reject gravity? How does anything stay down?
They propose the whole disk is just accelerating upwards, constantly, at 9.8 meters per second squared.
Which is, hang on, that's the acceleration due to gravity.
Exactly. So that upward acceleration feels like gravity pulling us down.
Wow, that's elaborate.
It is. It shows the lengths they go to make the model fit observations, sort of.
So if it's not just about people not knowing the science, I mean, clearly they've thought about some physics,
Yeah.
even if it's alternative physics. What is the root cause?
Well, Landrum's research really points away from just lack of education.
Yeah.
It seems to be much more about a deep, profound distrust. Distrust of authorities, institutions, science itself, often.
Wow.
It connects to a wider conspiracy mentality, where that ability to judge who to trust and when to be skeptical gets, well, fundamentally broken.
So it's less about the shape of the Earth and more about who's telling you the shape.
In many ways, yes. It's about rejecting the official story. McIntyre, the philosopher, he noticed that most flat earthers he met also believed other conspiracies.
Like what?
Oh, chemtrails, governments controlling the weather, that kind of thing. But the one thing he said all of them had in common.
Let me guess. Moon landing.
Bingo! They all believed we hadn't gone to the moon.
So if you show them a picture of Earth from the moon.
Fake. Just another part of the NASA conspiracy. It's all tied together in this narrative of deception by powerful groups.
And you mentioned YouTube earlier. How big a role did that play?
Huge. Landrum found almost everyone she spoke to got into Flat Earth through YouTube, either directly watching videos or someone sent them one.
Wow. Why YouTube specifically?
Well, the videos often throw a ton of arguments at you really fast. She called it an illusion of fluency.
Illusion of fluency.
Yeah, it's like the speed and the sheer number of points makes it feel like it makes sense, even if the arguments themselves are weak or easily debunked. Our brains kind of fall for that rapid-fire delivery.
That's a bit scary. Something to watch out for generally online.
Definitely. And then, crucially, the algorithms kick in.
The recommendation engine.
Exactly. It suggests more flat earth videos, more related conspiracies. It normalizes it, makes you feel like you're part of a community discovering hidden truths.
Didn't YouTube try to fix that?
They tweaked the algorithm in 2019, yeah, to reduce recommending conspiracy stuff. But the videos themselves, they're still there, easy to find if you look.
Which leads to this weird standard of evidence they seem to have.
How do you mean?
Well, it feels like the bar is super low for anything that confirms their belief,
Right, they'll accept almost anything.
but impossibly high for anything that challenges it. Like, photographic evidence from space isn't good enough.
Absolutely. It's a completely paradoxical approach to proof. Weak evidence for, impossibly strong evidence against.
Okay, so we've talked about the why. Let's switch gears. What about the actual, simple, elegant proofs for around Earth? Things maybe people can even check themselves.
Yes, let's do that, because some are beautifully simple. Take the disappearing ships.
The classic one?
Right. If Earth were flat, a ship sailing away would just get smaller and smaller, but you'd see the whole thing until it vanished.
But that's not what happens.
No. It disappears hull first. The bottom vanishes before the mast does, like it's sinking over the edge of the curve.
And you mentioned something you can try yourself.
Yeah. Watching a sunset.
Yeah.
Lie down on the pitch. Watch the sun dip completely below the horizon, then quickly stand up,
Yeah.
and you'll see the top of the sun briefly reappear, because from your higher vantage point, you can see slightly further over the curve. Simple visual proof.
That's cool. What else?
Shadows are another great one. Think back to Eratosthenes.
The sticks.
Exactly. If Earth were flat, the sun's rays would hit everywhere at the same angle. So identical sticks in different places would cast identical shadows at the same time.
But they don't.
They absolutely don't. The shadow lengths vary depending on where you are. Because the Earth is curved, the sun hits different spots at different angles.
And that explains time zones too, right? Different sun angles.
Precisely. And why sunset happens at different times across the globe? It's all down to the curvature and rotation.
What about the moon? Lunar eclipses.
Yes. During a lunar eclipse, the Earth moves between the sun and moon and casts its shadow on the moon.
And that shadow is...
Always round.
Yeah.
A perfect circular shadow.
Now, hang on. What if the flat Earth is like a spinning coin? Wouldn't it sometimes cast a circular shadow?
Good point. That's a common counterargument. But think about it. If it was a flat disk, the shadow's shape would depend on how the disk was oriented toward the sun and moon at that moment. Sometimes it might be a circle, yes, but other times it should be a thin line or an oval.
Ah, I see.
But the shadow Earth casts during a lunar eclipse is always a circle, no matter what time of day or night it occurs for different parts of the Earth. That only works if the Earth is a sphere.
Okay, that seems pretty conclusive. Then there are the more physics-y proofs, like Foucault's pendulum.
Right. Léon Foucault's experiment in Paris, 1851. A massive pendulum, swinging freely.
And it doesn't keep swinging in the same direction.
No. Over the course of the day, the plane of its swing appears to rotate. But it's not the pendulum changing, it's the Earth literally rotating underneath it. a direct demonstration.
Though I bet flat earthers have an explanation for that too.
Oh, they do. They often claim museums use hidden magnets or motors to make the pendulum rotate. Fraudulent, they say.
Of course, you almost want to build your own just to show them.
Ha, indeed.
And what about the Coriolis effect? That's about rotation too, isn't it?
Yes, it's an effect of inertia on a rotating sphere. It causes large-scale things like weather systems, hurricanes, cyclones to spin in opposite directions in the northern and southern hemispheres.
Anti-clockwise in the north, clockwise in the south.
That's the one. It affects ocean currents, too. And it's even significant enough that long-range military snipers actually have to account for it. Seriously. Snipers have to account for the Earth's rotation.
For very long shots, yes. The bullet travels far enough for the Earth to rotate slightly underneath it, causing a deflection. Real-world, high-stakes physics of a spherical Earth.
Wow. Okay, but flat earthers also claim they have photographic proof, right? Like seeing cities from really far away across water.
Ah, yes, the Chicago skyline from across Lake Michigan is a popular one. They say, look, it's 100 kilometers away, you shouldn't see it over the curve, therefore Earth is flat.
But you can sometimes see it, so what's happening there?
It's usually a mirage, specifically a superior mirage.
Like seeing water on a hot road?
Sort of, but inverted. In this case, you get a layer of cold, dense air right above the lake's surface, with warmer air above that. This temperature gradient bends light rays downwards, following the Earth's curve to some extent.
So it makes distant objects look higher than they are, or visible when they could be hidden.
Exactly. It looms them up over the horizon. It's atmospheric refraction, not a flat Earth. They also put a lot of faith in, like super zoom cameras. The Nikon P900 is famous, trying to zoom in and prove things aren't disappearing.
Yeah, almost a religious faith in the camera lens to reveal the truth the naked eye misses. But it's often just capturing these mirage effects.
It's interesting how some scientists have tried to engage them differently. You mentioned a simulation.
Yes, that was Bruce Sherwood, a retired physicist, and Derek Roth. They built a 3D computer simulation, but based entirely on the flat earther's own model, the US model, with the small, close sun.
And let people explore it.
Yeah, virtually walk around on this simulated flat Earth. And what they found were huge problems.
Like what?
Well, for instance, in their model, the sun's apparent size and brightness would have to change massively between sunrise and noon, like more than double, which obviously doesn't happen in reality.
Right, the sun looks roughly the same size all day.
And the stars were wrong, too. In the simulation, constellations just circled overhead at a constant altitude in the northern hemisphere instead of rising in the east and setting in the west like they actually do.
So they use the flat Earth assumptions to show the consequences don't match reality.
Exactly. It's clever because it meets them on their own ground, using their own rules, and shows how it just doesn't work.
So wrapping this up, what are the bigger implications here? Is this just a quirky belief system, or is there more at stake?
Well, Lee McIntyre, the philosopher, he voiced real concern. He worries that if it's just ignored or laughed at, they might try to push it into schools.
Like the intelligent design movement tried with evolution.
Precisely. He called their reasoning infectious and warned that, if the scientific community doesn't engage constructively, they'll just keep recruiting.
But is arguing the physics the best way? Landrum seemed skeptical.
Right. Her work suggests it's often not about the physics arguments themselves. The root issue is trust.
Trust in science, in institutions.
Exactly. So she argues the focus needs to be on rebuilding that trust. And maybe doing it face-to-face, not just yelling online.
Taking their questions seriously, even if they seem absurd.
Yeah, genuinely engaging, not being patronizing. It's hard, maybe excruciating, she admits, but potentially more effective.
There was that example with the NASA boss, Jim Bridenstine, right?
Oh, yeah, that's a fascinating case. Before he took the job, he was on record questioning climate change science.
But then he changed his mind.
Within months of being at NASA, he said scientists he grew to trust presented him with the data, and he publicly admitted he was wrong.
So trust was the key factor there, not just data dumps.
It seems so. It shows that changing minds on these big identity-linked issues is possible, but trust is often the missing ingredient.
Which brings us back to the flat earthers themselves.
Yes, and the intriguing paradox McIntyre pointed out. Many have this spirit of curiosity. They do experiments.
But don't accept the results if they contradict the belief.
Often, yes. They aren't always prepared to change their minds based on their own findings, which is why McIntyre really urged scientists, physicists, not to just laugh.
Because while we're laughing,
they are recruiting people, as he put it. We need to engage, not just dismiss.
It really underscores through this whole deep dive that it's about so much more than just facts versus fiction.
Definitely. It's this complex knot of trust, authority, identity, community. How people form beliefs is complicated.
A real reminder that even with undeniable proof, belief is, well, it's a powerful thing.
Absolutely. So maybe the thought to leave everyone with is this. If you have people who are genuinely curious, even willing to experiment, but are resistant to changing their minds when the results don't fit,
Hmm.
how do we bridge that gap?
Does our usual way of explaining the scientific method need adapting?
Perhaps.
Yeah.
How do we reach those who fundamentally distrust established knowledge? What do you think is the best way to encourage critical thinking when we're all swimming in so much information and misinformation?